Hi everyone, welcome back to our channel. Today we are going to discuss about what is meant by an class B chopper and why it is called as second quadrant of operation, and it is also called as step up chopper, and here the mode of operation is forward regenerative braking mode. So coming to this chopper, already I discussed the purpose of this chopper is to have an fixed DC value into an variable DC value. Input is fixed but output is 0 to 12. So here in this example we will consider the input voltage as 2 we are applying and output voltage will be an higher voltage. That's why input is only 1 but output is 2. Here I am going to call this as step up chopper. Let's try to see the how it happens through the circuit diagram. When you come to the circuit diagram, so here you are going to have an voltage we are applying, and we have the configuration here. So we have the configuration, a diode, and we are having an transistor connected like this, and here we are going to apply the control signal, where the control signal here is the base current, and here we have the inductance of our DC motor as well as armature resistance of the DC motor, armature inductance of the DC motor. When you are operating a DC motor, there is an EMF which is generated in an DC motor, where this EMF you are going to call it as back EMF. The formula for back EMF is also similar to the generated EMF, which is nothing but 5Z NP by 60A. So now this is the original action, and this I am going to label as a diode D1, and this is nothing but the transistor, and we are going to have an source voltage Vs. So this is the original picture of our circuit. Now let's try to understand how the operation proceeds in this class B chopper. Okay, so here when you come here, try to draw the waveform of this chopper. So when you observe this, we are going to have the base current, which is nothing but the base current what we are supplying to the transistor. The base current is like this. Okay, it is having a magnitude here, and I'm taking only one cycle for better understanding. So I'm going to draw the base current. So here I'm taking the base current like this. So this is first half cycle, this is 0, and first half cycle is delta t, and second half cycle is t. And now what is the action of this network is here this back EMF is the source. Okay, so let's try to draw the circuit diagrams separately in such a way that we can understand better. So here back EMF is the source. Okay, in this duration only you have this network, and you have an inductance of the armature and resistance of this armature, and here already I told this is the back EMF available in higher amount. But in the case of an electric vehicle, basically here this will be acting like a motor. When you are operating in negative slope, this motor will try to act like an generator, and this EMF will be of higher value, and this generator means this will generate the EMF of an positive value. That's why we are saying this as an back EMF. This motor acts like a generator, and this is like an source. Whenever the current is coming in this direction, we are calling this current as with negative polarity, and this current we are going to label as a armature current, and this inductor as a armature inductance. And now you can see here the current flows like this, and it is going to charge the inductance of the motor. So the current flows like this, and it flows across this BJT, and it establishes a closed path. So like this it establishes a closed path, and now your inductor is charged. Now the inductor is charged. Let's try to draw the output currents. So you can see here what is the magnitude of the output current. It's armature current we are calling. I am calling this armature current as some minus I naught, or you can call it as minus IA. So now what's happening? The inductor is charged. The inductor is charged, then automatically what happens is the inductor is slowly charged and it reaches the interval of delta t. Now inductor is charged, but after this time it reaches from minimum current to maximum current. Now the inductor is fully charged. Now when you come to the second cycle, what happens here is here the base current is available, or the control signal is available. Since this control signal is on, the inductor is getting charged. Now we are going to make this control signal off. We are going to make this as a open circuit. When you make this as open circuit, how the operation is, so inductor is already there and resistor is also there, and our back EMF, what we call the generated EMF from the electric vehicle. So this try to flows across the diode D1 and it flows into the source, where this voltage we are going to call it as source voltage, where we are going to call this as a load. Okay, so now this the inductor is already charged. So inductor was charged with the polarities of positive and negative. Previously it was charged with positive and negative. Now let us see here how it and discharges. Already I told inductor doesn't allow sudden changes in current. Here it is charged as positive and negative. Now it will discharge as, it will try to discharge as, this is positive, it will change its terminal and it will make our current to flow in same direction, and the diode conducts and it goes to the source, and that's how the current is flowing. So I can say that our inductor has reversed its voltage polarity. So reverse of voltage polarities and making the current IA to have continuous in nature. Okay, it allows the current to flow in continuous in nature, and it makes the current IA to flow continuous in nature. Okay, so that's what the importance of this inductor. And you can see here now, coming to here, the base current we have been removed and it's already open circuited. So whenever it is open circuited, the current is still flowing. So now what's happening here, the current is trying to discharge and it is coming discharging from maximum current to minimum current. So it is coming from maximum current to minimum current. Now when you draw the output waveform, let us try to experience how it is there. So we are going to draw the output voltage. So output voltage, which is nothing but the average value. So you see here, in this condition what's happening, so I naught is flowing and this is acting like an short circuit path. Okay, so whenever this is acting like an short circuit path, automatically the inductor is the switch is closed. What is the output voltage? 0. So therefore I am going to get the output voltage is 0, and whenever you remove the switch, automatically what is established? Some voltage is established. Why? Because it is open circuited. Now open circuited, what is there? Voltage is there, and what is the magnitude of output voltage? Is this equal to the source voltage? Okay, why? Because this connected in parallel. If you neglect this, these two are connected in parallel. So this, the voltage across the switch will be again increasing. Okay, again it maintains its magnitude of V, or voltage source. Now here you can see here the energy is flowing from where to where? Load to source. That's why this is called regenerative mode of operation. Okay, so when you come to the quadrant operation, so this is how it's happening. There is a derivation part, how to handle this part, and we are going to get the output voltage across the armature, which is nothing but source voltage divided by 1 by delta, and the delta I am going to vary from 0 to 1. Let us assume that source voltage I have been applied 1 volt divided by 1 minus delta, I am taking it as 0.5. So 1 divided by 0.5, which is nothing but 5 by 10, this is nothing but 2 volts. Now how much voltage applied? 1 volt. What is the output voltage? 2 volts. Therefore I can call this chopper as an step up chopper. Applied is 1, output is 2. Therefore, I am calling this chopper as a output voltage, where VA is nothing but output voltage or across the switch. Why? Because they are directly interconnected. Okay. So this is how we are going to call it as a step up chopper. And when you come to the quadrant operation, already we have been on the quadrant operation. So here we are going to have positive current, here we are going to have the negative current, here we are going to have positive voltage as well as negative voltage. Already in the previous chopper we have been obtained the characteristics of class A chopper, where the voltage is positive and current is also positive. But when you come here, already you can see here what is the amount of current, negative. So negative current is there. Okay, so negative current is there. And what is the voltage we are going to get when you multiply this voltage? So minus Ia into the drop across the load. If you consider this all are negligible, source voltage these are of same, so Ia into Ra, we are going to get so this the same current is trying to flow, automatically you are going to get Va, which is nothing but an, so negative into negative we are going to get it as an positive voltage. Therefore we are going to have an positive voltage. So here the previous it was acting like a motor, and this motor is trying to act like an generator. In this generator mode, it is generating how much amount of current, negative only current, but the voltage is same. Therefore I can say that our class B chopper operates in second mode of operation. Okay, so here we are going to call it as a forward, for electric vehicle is called as a forward motoring mode of operation. Means like this is called forward motoring mode of operation. So this is called as forward regenerative. Why? Because that motor is acting like an regen. Here this generator we are going to call it as back EMF, regenerative mode of operation. And here the vehicle still try to rotate in same direction. Okay, electric vehicle is rotating previously like this. When you remove the acceleration, still the vehicle try to rotate in same direction, which was acting like a motor, now will try to act like an generator. And it operates in which quadrant? Second quadrant. That's why this is called forward regenerative mode of operation. I think all our points are fulfilled now. So this is class B chopper, which operates in second quadrant of operation, which is a step up chopper which fulfills the forward regenerative braking mode of operation. This is all about class B chopper. And if you feel the content you are able to understand better, please like the video and please share with your friends. And if you have any doubts, I can answer your doubts. Please let me know in comment section. And thank you for, if you're watching first time, please subscribe our channel and please share with your friends to do the subscription. So this is like an free channel for the development of students, for sharing the knowledge. So thank you for listening patiently. So yours obediently, Ram, will meet in the next video. Thank you for watching.